Hello and welcome to step 5 in coding the line sensors on the Wizibot. In this step we are going to be adding drop detection to the code. Obviously you need to have completed all the other 4 steps and then have tested your robot on the lines. It should be driving around the lines perfectly well. If it's not doing that, obviously get that working first and then come back for the drop detection stuff. So first up, what is the drop detection and what is it we're trying to achieve? Okay, so the real question is, how do we prevent our robots from falling off an edge? For example, our Wizibots are going to be driving around on the desks. We don't want them falling off onto the floor. So a drop detector effectively tries to detect when there is a drop underneath the sensor. Okay. In the case of a reflectance sensor, it's simply no reflectance coming back because there is nothing to reflect from. Okay, so with the reflectance sensors, what we're going to be looking for is a severe drop in the amount of light that is being reflected to the sensor. Now, other robots, obviously, that may use this are things like robotic hoovers. Okay, they're going to do it to try and avoid the stairs or significant drops around the home. And then you may also have robots in the fields and farmers' robots that are trying to detect things like ditches and stuff like that, so they don't get stuck. Because obviously, if they drive down into these ditches or they fall into the ditches, they can become damaged. Now, the positioning of drop sensors is very important. Okay, in the case of the Wizibot, we're trying to use it for 2 things. We're trying to use it for both the line detection and drop detection. Okay, so we've kind of gone for a bit of a hybrid approach as to where we put them. We place them at the front left and front right of the robot. Now, these drop sensors are not wider than the wheelbase of the robot. That means that if the robot is driving directly forwards to the edge of the desk, it will be absolutely fine. However, if the robot is driving at a slight angle to the side of the desk and that wheel goes over the side of the desk before the sensor goes over the side of the desk, it won't detect the drop correctly and the robot will fall. Ideally, with the Wizibot, we would have the sensors located wider than the wheels. Okay, so just bear that in mind when you're doing the testing with these robots. It's only because we're using them for both that line detection. If we put that as the line detection as well, and we place that wider than the wheels, the robot would drive a significant distance before detecting the line change, and it would essentially very erratically zigzag across the desk. So we're kind of trying to find that hybrid point. It's obviously important as well to note the direction of travel of your robot. There's no point having drop sensors on the back if it never drives backwards. Okay, so you're going to put the drop sensors towards the front. On many robot hoovers, they are actually round hoovers. Okay, and then they have the drop sensors all the way around the front edge, all the way to the left, all the way to the right, and then there's normally one in the center of the front. Okay, so just bear in mind if you're doing drop sensors, make sure that you position them correctly so that they detect the drop before any of the wheels go over the edge of the drop. So let's modify code and actually try and get this drop sensor code into our Wizibots. First thing I want you to do then is modify the motor control.ino, and we're simply going to add a drive backwards function. So add this now and then resume the video. All this code does is simply set the left motor direction and right motor direction to low. That causes both motors to go in the reverse direction, hence the robot will drive backwards. Next, I want you to open up the line sensors tab, and I want you to add the following function, modify code, and then resume the video. Once you have modified the code, let's have a quick look at the code. We have added a new function called sensor can see drop. This is very similar to the sensor can see line function that we had before. Now, the only real modification or difference between these 2 functions is that threshold that we're going to be using. Before, we used a 90% threshold. Okay, so had to have a drop of at least 10% before it would register that as a line underneath the sensor. In the case of the drop sensors, we're going to go for 50%. Okay, so it's a significant drop in the amount of light that's reflected. And that's pretty much the only real difference. If it detects a drop, it will return true. If it doesn't detect a drop under the sensor, it will return false. Now what we're going to do is modify the loop function in the main sketch. Okay, so I want you to modify the following code, very simple change, and then I'll explain it. Okay, now we've made that modification. All we are doing here is simply calling a function to check for drops. We're going to write that function next. Okay, it's important to remember because we have an if statement there. We're opening a curly bracket. We need to make sure that we close the curly bracket at the bottom there. So make sure you've modified 3 lines of code there. The other important thing to note at this point is that the check for drops is being done before we do the check for lines. Okay, we want to know if this robot is over a drop before we do all the code related to the lines. Otherwise, we might continue to follow the line off the edge of a desk. We don't want to do that. The most important thing is to avoid the drop, and then we can do the line sensing. So the order in which we do this is important. We check for drops first, and then we do the line sensing if a drop is not detected. Next, in the same main sketch file, right at the bottom below your loop function, I want you to add the following code. Resume the video once you have typed it in. Now that you've typed in this code, let's have a quick look at what the code does. Okay, the first thing this function does is it checks the left sensor to see if it can see a drop. It makes a call to that function that we added into the line sensors tab. Okay, passes in the left line sensor pin, passes in that baseline for the left sensor, just like we did when we were detecting the lines. Only now that function is going to check for a 50% drop in the amount of light reflected. If it sees a drop, so if it returns true, the robot will drive backwards for 1 second, it will turn right for 1 second, and then it will resume driving forwards. So the idea now is it's avoided the drop. Now the function at this point will return true. Okay, so it's true that it detected a drop. That's going to return true to the main calling function in the loop. If it doesn't detect a drop on the left sensor, it will do exactly the same for the right sensor. So it'll do a check on the right sensor pin with the right sensor baseline. If it detects a drop, it will drive backwards again for 1 second, but this time it's going to turn left for 1 second before resuming driving forwards. So we're doing two different things. If it detects it on the left side, it will reverse and turn right. If it detects it on the right side, it will reverse and turn left. This is all in aid of trying to avoid that drop. The sensing on the next loop call on the Arduino will also do a check for the drop again. So if it continues to detect a drop, it should continue to try and avoid that drop. Okay. Again, on the right sensor, if it detects a drop, it's going to return true to say that it's handled the drop and that it has done code related to the drop, so it doesn't want to do any line sensing. If no drops are detected, the function will return false. Okay, if it returns false, then the line sensing code in the main loop function will run and it will actually resume that line following. Okay, so if it detects a drop, it will do the drop code and avoid the drop. If it doesn't detect a drop, it will resume the code related to following a line. Okay, so that's the end of the code for the drop sensing. What I want you to do is upload the code to your Wizibot. Once you've done that, I want you to plug in the battery and then place the robot so that it directly faces the edge of your desk. Okay, be ready to catch the robot. Okay, press button B1 and the robot should drive forwards. When it gets to the edge of the desk, if it's working correctly, it should detect the drop, reverse and turn to avoid the drop. Again, be very careful, be ready to catch it. It will then drive forward again, and then obviously when it detects the edge of the desk again, it should again try to avoid. Just bear in mind, obviously there is that limitation with the Wizibot. It's not perfect for drop sensing. If one of those large wheels goes over the edge of the desk before the sensor goes over the edge of the desk, so if it's going at an angle, then the wheel will come off. The robot may detect the drop, but it's too late by then. It can't avoid the drop. It's already tumbling off the table. Okay, so just be careful. Don't leave them just leaving them running. Just be careful and always be ready to catch them. Now, if you take that robot and also place it onto the line circuit that we've got before from last session or last video, then you'll notice it continues to follow the line. So it still has that line sensing code in there. If you have a line that goes over the edge of the desk, it might be worth trying this. Just have a piece of tape that goes off the edge of the desk. The robot will follow the line until the edge of the desk. And then, again, be ready to catch it just in case. But it should detect the edge of the desk, reverse and turn and avoid. Now, during that avoidance, it's not doing any line detection. Okay, so just bear in mind that once it finishes its maneuver to avoid, it's then going to start seeking for the line again. It may have come off the line, it may just drive off randomly. Okay, so just, again, be ready to catch it. But it does demonstrate how we can use the line sensors for both line sensing and also that drop detection. So it's a reflectance sensor. It has multiple purposes based upon how we code it. That is the end of the line sensing stuff. Next week, we will move on to something like ultrasonics.